This Arduino project involves using an Arduino Nano board, a BMP 180, which is a Bosch Barometer board, a DAC, and several other components to make this turn this voltmeter into a barometer. So we started with searching through eBay and found a large panel meter. Here we can see the original panel meter. It had a black bezel on it, and it had a 0 to 6 volts on the plate. You can see the overall diameter is almost 6 inches. The active area is a little less than 5 inches. So the idea was to make something that looked like a steampunk barometer. And I wanted it to be somewhat elegant, have a brassy finish to give it that steampunk appearance. So what we did was had to figure out a couple of things here. The first was how to figure out how to repurpose the 0 to 6 volt meter, and you'll see this in the GitHub files that I published, GitHub that will be in this video. You'll be able to look up the code and some of the other things that I did to make this, to realize this. Okay, so what we did was we had to basically take the 0 to 6 volt meter, and to repurpose this into a barometer round meter, I used a software by Tonne, T-O-N-N-E, that allowed me to print new meter faces. Okay, this is actually photographic paper, which you can get, and I just printed the meter face on photographic paper, and then I had, using X-Acto knife and scissors, cut it out, and then so I could slip it under the needle here. All right, I had to take these 2 screws out, remove the metal plate that was the original meter, made all the measurements, cut the holes here to match the screw positions here. And that was probably the hardest part of this, was to make the meter face and get it exactly right. The program itself is called Meter, and this was my first crack at it, and I changed the scales a little bit. You can actually see there's an offset here so that we can get inches of mercury and millibars around the outside edge, and it took a little while to get that just right, but I think it came out fairly professional. Okay, if we take the meter apart here, you can see the terminals for the 6 volt voltmeter. This is the Arduino board right here. The pressure sensor, which is a BMP 180, is sticking right here. Oh, down here we have a DAC. This is a 12-bit digital to analog converter. So the Arduino is reading the pressure digitally over the I2C bus from this Bosch barometric pressure sensor, which is very accurate. And then what we do is we convert that pressure into an analog voltage, which is then written, well, the analog voltage is generated by the DAC here, 12-bit DAC, digitally from the Arduino Nano. Now, because this is a 6 volt meter, I had to be able to get from the 5 volt output of the DAC up to 6 volts. So that required putting an op amp in here and providing a gain of 1.2 to scale that 5 volt output from the DAC up to 6 volts total, because I wanted to take full advantage of the panel meter's 0 to 6 volts. So we needed a voltage regulator here, and you can see I put this together on a prototype circuit board. It's not a PC board. It's just perf board, and these are all hand soldered connections. And this took like probably about, I'm gonna say about 3 hours to build. So not too bad, because there's not a lot of connections on here. Then he also added a couple of quick disconnects on here, screw terminals. This one here goes over to the 12 volt power supply, which is just a wall wart, and this here connects to the meter. The case that it's in, I did a terrible job painting this, but you get the idea. This was actually a piece of 6-inch sewer stack, and I cut that using a Sawzall filed it down a little bit, and then painted it gold to match the appearance of the meter here. This originally was black, and I used acetone to get rid of the black paint on it. Wipe that off, and we got the nice brass finish here. The software to actually put together the scale, the new scale on here, is fairly easy to use. It took a few hours to get good at learning how to manipulate the software, and Jim Tonne over at Tonne Software, who wrote the meter program for scaling this, also gave me a couple of hints on how to get this thing to look right. So I think it came out pretty good. Looks fairly professional. I still have to finish up a few things here. I want to repaint the side here, this PVC tubing, so that it's got a better finish on it. I'm waiting for the weather to get a little bit nicer before I do that. And I also got to figure out how to fasten this to the PVC pipe, and I'm also got to build a back side to the meter so I can hang this on a wall. Right now it's oh, I should point out one other thing on here. So on this board, right here, you can see there's a trim pot here, and this is used to offset the your barometric pressure for your area, to make it relative to sea level. So essentially what you do is you get the barometric pressure off your cell phone, and then you adjust this little trim pot here to get the correct reading. So what that does is it corrects your altitude, because all barometric pressure readings are done relative to sea level, not to your height above, not to your not to your height above ground level. Okay, so I'm about 400 feet above sea level. I need to compensate that out. The meter itself is very accurate. I've been tracking this versus the barometric pressure at Albany Airport, which I live close to, and we're within less than 1% accuracy on this thing, so I'm very happy with its accuracy and its appearance. Also in the code, when I wrote this, I added in, from an older project, there was 4 LEDs that you can hook up to this that would allow you to also note if the pressure is rising, decreasing, rising a little bit, or rising a lot. So with 4 LEDs, you can get 6 pieces of information. I was originally going to put those LEDs down in here, but then at the last minute, I decided I didn't want to ruin the nice appearance that I had and skip putting LEDs in. But the code's in there if you want to do something like that in your project. Okay, here you can see the meter software. This is a preview image of what the scale looked like. Here's the plate design, where you have to put the dimensions in. This is the scale design, where you can adjust the full scale and minimum scale readings. Then the graphic entry, which is the units, inches of mercury, millibars. This is the finished thing we printed out. Alright, here we have the meter disassembled. You can see the original 0 to 6,000 or 6 volts or 6,000 millivolt scale, and there's an inner bezel, an outer bezel with the glass window on it, and then the metal plate that the original scale was printed on, that I glued my new scale to. Real quick, here is what the original prototype board looked like to prove everything worked before I made the soldered it together on the prototype board. So it looked kind of messy, but I was able to shrink the geometry down quite a bit to fit it in with the meter. Thanks for watching this, and if you have any questions, you can always shoot me a reply in this video, and I'll try to get to it and answer it as quickly as possible. Thank you.